Predict for the percent of outpatient surgeries in 1998. So what number do you have to plug in? 98, right? X. It says X is the number of years since 1900. So what number do you plug in? F of what? Of 98. It says where X is the number of years since 1900. It says in the phrase where X is the number of years since 1900. So then, what do you need in order to do this? Your calculator. Just say calculator. There you go. Yeah, you have to use your calculator. You're not going to be able to do that by hand. So if you do this on your calculator, negative what, 1317, right? Plus what? Oh, clear. Negative 1317 minus ln of plus. Thank you. Plus ln of what? What are we plugging in again? 98. 98. Oh, I can't even type this. I mean, I'm doing a terrible job on this. Plus 304 ln of what? Yeah, there we go. There's the 98. There it is. So then I hit enter and end up with 78.83 right there. Wow. I can almost read and type today. It's a stunning start to the day. Okay, so we plugged in the proper values. How many of you plugged in 1998 and not 98? Yeah. Careful, careful. So that's important right there. Ooh, I'll even highlight it. There you go. Okay, so next it asks, when does outpatient surgeries reach 50%? So what do we have to solve? So we know that this function, the output is the 50%, so we want the output to be 50. So what equation do we need to solve? Can someone read the equation we need to solve to do B? 50 equals.
Wouldn't you have to put in a decimal percent?
Okay, Liv is talking right now. Please don't. 50 equals what?
Plus 304.
Yep.
Ln x.
Correct. The output of this is the percent. It tells us that. Where X, it says the growth of outpatient surgeries as a percent of total surgeries. It's giving you it in percent. You don't have to convert anything. So this right here was already, the formula is written so that this is the percent of outpatient surgeries. So 50 is equal to that. So what are we solving for?
50. Or how many?
We're solving for X, yeah. We're solving for how many years is it going to take to get to 50%, right? So how do we go about solving this? Tell me, what's the first step? What's the first small step I can make? Liv. Correct. So I end up with 1,367 is equal to 304 ln x. Can someone tell me next what I should do? Raise your hand. What should I do next? Jen. Yeah, Harry. Exactly, right. So you end up with 1,367 over 304 is equal to ln x. What do I do now? Can someone tell me what I do now? What form is that in? Yeah, what form is that in right now? So what should we put it in? Exponential form. What is ln x? Base what? So you have, I'm just rewriting this, it's just notation. I'm not doing any math, I'm just doing the notation. It's log base what? E of x. So if we want to convert this to exponential form, can someone tell me what it is in exponential form? Someone who hasn't spoken yet today? Can someone convert that to exponential form for me? What's the base? What's the base? No, there's no log in exponent form. E to the, yep, over 304 equals what? Equals x. You convert it to exponential form. So the first thing we learned how to do is convert between the two. What's the coefficient in front of ln right here? What's the coefficient? 1. Is that good for you? Yes, you want it to be 1 or you can't do this conversion. So now what do you just need to use your calculator. So what do? This is how I would do it. 1,367 divided by what? 304? Is that correct?
Yeah.
And then I would do second e. Where's e? There it is right there. E to the second answer, like that. Oh, that's, let me show you something. Second a and x, it's under the minus sign. You see how it says e to the a and s right there? That means the last number. So then I'm hitting enter. There it is, right there. There it is, right there. So what year does that represent? 1989. Yeah, in like a little bit into 1989, right?
Can you do, I did second instead of second, do second for ln, because that's still okay.
There's no ln in this right here.
No.
Oh, the button you pressed, you mean?
Yeah.
Yeah, you press second ln, that is e to the x. Sorry, you press second ln, and that gives you e to the whatever you want it to be. Yes, exactly. To a question. Let's go back to a question that I asked you and showed you, actually, a while ago that we couldn't answer before. Here's the question. 3 to what power equals 12? Let's see if you can figure out what power you need to raise 3 to. I need it to 3 decimal places. We'll have a little competition. Let's see if you can figure out 3 to what power is equal to 12. Of 12. Correct. So now you know what x equals, but you need to get the decimal for that. And yesterday I showed you how to get a decimal for that. Do you remember how to do that? Can someone tell me? Alex and Milo?
Yes.
Can you pay attention? Thanks. Hannah, yeah?
You're going to do log 10 of 12.
Log base 10 of 12 over.
Log base 10.
Did it have to be log base 10?
Yeah.
Why? Why is log base 10 the one you chose? Correct. Your calculator does one other one you could have used if you wanted to. You could use ln. Either one. What should you get either case?
Well, same answer.
You should get the same answer. What do you get? Can someone tell me what you get to 3 decimal places? What do you get, Connor?
2.262.
2.262. This should come out to be 2.262. How do you check this to see if it's correct? What do you do with this 2.262?
Plug it in for x.
Yeah, you do 3.262, and it should come out to be? Try it. Let's see what happens. You said 3 to the 2.262.
12.001.
Yeah. So the thing is, was it rounded a little bit when you did that? Yeah. So do you expect it to be really close, but maybe not exact? Absolutely. Logarithms are going to be irrational and go on forever. So whenever you round it, it's going to be a little off. Yeah, it's going to be a little off. Okay, that's not that bad. So what about if I gave you this one right here? Let's say 6 to the x power is equal to 94. Do that for me. More interesting. A little bit more interesting. Let's say I gave you this. E to the 0.003x is equal to 40. See if you can solve log base e of what?
40.
Equals. Yeah, exactly. So can you get a number for this? Yeah, that's going to be log of 40 over what? Log of e is equal to this thing. So can you get a decimal for this? Can you plug that into your calculator right now if you wanted to? Yes. If you wanted to isolate x, what's the only added step you have to do to this right here to isolate x? Divide by 0.003. So what is x going to be? Log of 40 over 0.003 times log of e. You can use your calculator now, and what can your calculator give you? A decimal. The only thing that is different about this one is that you had to divide by what? Divide by this number, right? This is the only thing that changed. Get a decimal and then raise your hand when you have a decimal. We'll have a little competition for the decimal. What did you get, Harry?
Oh, I was just asking questions.
Okay.
2 to 4 equals x plus 5.
What are you solving for? Pony or x? Okay. What's 2 to the 4th?
16.
So we have 16 is equal to x plus 5 to the 3rd power. How do you get rid of a cube? Cube root. So now we know that the cube root of 16 is equal to what? So if we want to isolate x, what is x going to be?
Cube root of 16 minus 5.
Yeah, so you can say negative 5 plus the cube root of 16. You're done. That's it. There it is. You're all done. Try to do if you can. Check your answers. Let's go back and look at the original equation. There are 2 potential answers. X equals negative 4 or 25. Both of them could be true, but let's check them. Can you plug in negative 4 into this?
No.
No, because you can't take the log of a negative number. So yeah, when we finish it, there's nothing wrong with our math. We're just checking our answers to see if there's like a false positive. Is there? Yeah. Negative 4 can't be plugged in. It's not in the domain. So what's the only answer to this? 25 is the only answer. 25 is the only answer. So on the test, when I give you one like this, I can guarantee you'll get one like this. You need to just look. It takes like 2 seconds. Just because a number is negative doesn't mean it's necessarily something you can't plug in. Like, for example, let's say I had log of x squared plus log of x plus 10. Can you plug in negative 4 into that? Can you plug in -4 into that one?
But it'll change to.
Positive, exactly. So can you plug in -4 for x into this equation, into this expression? Yeah, because -4 squared is positive, and -4 plus 10 is positive. So just because it's -4 doesn't necessarily mean it can't be an answer. But on this one right here, can you plug in -4 right here? No. So you just have to do a quick check. Is it in the domain? So the last part of this section right here is a really, 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 really important equation that maybe some of you have seen before, that you definitely will use in your life. So everybody stand up for a second. You're not going to have to memorize this. You're not going to have to memorize it, but it's something that you're going to see, and hopefully you will eventually memorize. Has anybody seen this before? Does anybody know what that models? Anybody want to tell me what I'm going to write? Well, we're branching out, huh? Compound interest. Can anybody explain to me what compound interest is? He said it has to do with money. Really? So what is this? This is $200 at, that's P. This is A. We're solving for it. $200 at 12% for 10 years. Compounded how often? Compounded how often did I say? Monthly, yep. Oh, 5%. Sorry, thank you. It's 5%. Thank you, Zoya. $200 at 5% for 10 years compounded monthly. So this is going to be how much money you have in your account after 10 years. This is what I'd like you to do right now. It's a little bit of a challenge because I haven't really shown you how to do this, but carefully, you should be able to. Tell me how much money is in his account. Round to the nearest. Now, does that make reasonable sense? Yeah, sure. I have a question for you. We're going to do the same thing, but I want you to make this one monthly instead. Do the same exact thing, but do it monthly. Do it monthly. Tell me what you get rate. So what was that rate on this question? 0.09, right? And how many years was it? 18, right? If I do that on my calculator, 750 times what? E to the, what was it? 0.09 times 18, right?
Oh, that's easy.
Look what I get. That right there, is that about almost exactly what we got before? So here's the deal. What have you just shown? So this is continuous interest. You've shown, look, you've just shown this right here is daily, right? This right here is monthly, right? So monthly, what's the difference between monthly and daily? It's only like, it's like $23, right? And then what's the difference between daily and continuous?
It's continuous like over the years.
Oh, continuous means every instant, like every millisecond this is being compounded. So we went monthly, daily, you could do hours and seconds.
Compounded every second, you have a lot more.
If you don't, what's interesting is that you get more because you're doing it more often, but you're doing very, very little interest all the time. So it kind of balances out, but what it means is the most you could ever make if it was continuous interest is this. This is the ceiling right here.
That's the max.
That's the max. You can't get any more than that. Okay, your homework is in your syllabus. Get out.